Let us discuss this example. So in this example, we have a function which is of three variables x, y, z. We have to find its gradient, okay, and the point is not mentioned. That means simply we have to find a function del f, okay. So let us find first partial derivative of f with respect to x. Consider del by f by del by x, derivative of f with respect to x. See, you know that addition is there, that means we have to take separate derivatives, as well as we are taking derivative with respect to x. So that's why y and z are constants for us. So cos x is a function of x and e raised to x is also there. So that means both are functions of x. So and multiplication is there. So that's why we have to use u into v formula to find its derivative. E raised to x y z cos x plus, if you think about the second function, there is no any x, so that's why it's a constant and derivative of constant is 0. X cube, its derivative is 3x square. Okay, so let us use u into v formula. The formula says first into derivative of second, derivative of cos x is minus sin x, plus second into derivative of first, derivative of e raised to xyz is e raised to xyz. Since you know derivative of exponential function is same, derivative of e raised to x is e raised to x only, getting? But see, the power is different. So that's why again we have to take its derivative with respect to x, xyz. So we call it as a chain rule, getting? So again I have taken the derivative of xyz plus 3x square we have. So this is equal to, if you simplify, this is minus e raised to xyz sin x, okay, plus cos x into e raised to xyz into, see, when you take derivative with respect to x, y and z are constants. So those terms will come outside. Y and z will come outside. So in bracket there will be x only. Derivative of x is 1. So that's why 1 into yz we will have yz plus 3x square. So let me write all these things properly. So this is equal to minus e raised to xyz sin x, okay, plus this yz cos x into e raised to xyz plus 3x square. So in this way we calculated derivative of f with respect to x. Now we will find derivative of f with respect to y. Now we will calculate del by f by del by y. Its derivative with respect to y. Addition, subtraction, we can take separate derivatives. Let us think about first. So cos x is a constant. Since we are taking derivative with respect to y, so x and all functions of x are constants. But see, here is some y is there, getting now? So it's not a constant, we have to find its derivative. What is derivative of exponential function? Same. So its derivative will be e raised to xyz, but power is different. So again we have to take derivative of its power. We call it as a chain rule. Here y is there, so it's a function. What is the derivative of cos? It is minus sin yz, but again derivative of that bracket yz. If there is y only, then no need to take its one more derivative. But it is different, getting? So that's why we need to take its one more derivative. What is derivative of last one? Y is not there, so it's a constant. Derivative of constant is 0. So this is equal to cos x into e raised to xyz. Here x and z will come outside and derivative of y is 1. 1 into xz, we will have xz. So this is equal, this is minus sin yz into, what will happen here? Z will come outside and derivative of y is 1. So z into 1 z. Yes, this one only. So I will write properly xz e raised to xyz cos x minus z sin yz. Okay. So see, after that we have to find derivative of f with respect to z, but there is no more space. Make a screenshot of it, then we will go further. Now we will find derivative of f with respect to z. Let us find. See, cos x is a constant. We have to find derivative of e raised to xyz. Derivative of exponential function is same. So it is e raised to xyz But again, we have to take derivative of this x, y, z with respect to z. We call it as a chain rule. Next, derivative of z is there, so it's not a constant. Derivative of cos is minus sign, so it's minus sine yz. But again, we need to take its derivative with respect to z, yz. X cube is a constant since we are taking derivative with respect to z and z is not there. So that's why its derivative of constant, you know, it's 0. This is equal to cos x e raised to xyz. See what will happen, x and y are constant, they will come outside. So derivative of z is 1 into xy we will have same, minus sine yz. Here y will come outside and z will be there. So derivative of z is 1. So y into 1 y. So this is equal to xy e raised to xyz cos x minus y sin yz. So in this way we calculated derivative of f with respect to z also. After that, all partial derivatives now we have calculated. So simply we have to put in that way in a definition of del f. So we will have a required answer. Make a screenshot of it, then we will go further. See, del f is equal to, you know that, del by f by del by x first component, del by f by del by y second, and del by f by del by z third component. All three values we have already calculated. So simply I put those values here. So we get a gradient of f. Let us discuss one more example. Just before that, make a screenshot of it. Let us discuss this second example. So in this second example, we have a function f of xy is equal to log x square plus 3y square. Obviously, x and y should not be 0 simultaneously. Okay, so we have to find again gradient. So you know that f is a function of two variables. So simply we have to find del by x and del by y. First of all, we have to write the given function. I have already written here. Let us find derivative with respect to x. Now, del by x, I am finding its derivative with respect to x. I will find directly. Okay, so see, there is only one function log of something. So what is derivative of log? 1 upon x. So that's why its derivative will be 1 upon x square plus 3y square. But again derivative of its bracket, which is x square plus 3y square. So this is equal to 1 upon x square plus 3y square into, after that addition is there, that means we can take separate derivatives. Derivative of x square is 2x and derivative of 3y square is 0. Since we are finding derivative with respect to x, that 3y square is a constant. So its answer will be 2x upon x square plus 3y square. So let us find derivative with respect to y now. Now, del by f by del by y. So again, the main function is same log. So its derivative will be 1 upon that bracket, 1 upon x square plus 3y square. But again, derivative of that bracket with respect to y. So 1 upon x square plus 3y square. So if you think about that bracket, there is addition, so we can take separate derivative. We are taking derivative with respect to y, and first is a function of x only. So it's a constant and derivative will be 0. Plus, see, 3 is a constant and derivative of y square is 2y. So its value is, combinedly we can say it is 6y upon x square plus 3y square. Then gradient of f, you know its formula, del by x, and second component del by y. F is a function of two variables only, x and y. So that's why there is no del by z. Okay, so this is equal to del by x, value we have got 2x upon x square plus 3y square, and yeah, second component del by y 6y upon x square plus 3y square. This is a required answer, providing, again I will say, x and y should be non-zero. Okay, it should not be equal to 0 simultaneously. Thank you. Bye bye.